All right, so let's learn one more input device today. That is the keypad, or we sometimes call this matrix keypad. So this is one of the keypad you have in your uh, IoT kit, and one you have actually has one more column, A, B, C, D. So it's still the same thing. So this diagram here only shows basically a 4x3 matrix keypad, but you have a 4x4. And you'll actually notice it has multiple leads coming out of this keypad. So we have learned what a button is, how to control a button. And this really is just basically a bunch of more buttons grouped together. And the way to control each button is through these wires over here. And for 4x4 matrix keypad, you'll have 4 plus 4, 8 of these wires here, the 8 leads. And this 4x3 will be 4 plus 3, 7 leads in total. The reason that is because to be able to control each button individually, you just need to pick the location of that button. So by using, 2 dimensions, and then you can find out, what button is on or off. So that's kind of really the sort of the mechanism to control this with this many wires. And a good way to think about this is the reason it's called a matrix is similar to the 2-dimensional arrays. Or yeah, if we're using Python, just say list of lists. So for example, if I have if I have a list of A, let's say looking at this particular keypad, the first row is 1, 2, 3. Second row is 4, 5, 6, and so on. So let's say we're going to just deal with these 2 rows. And of course, to identify, let's say, index 0, 0, that gives you the, the button number 1, right? So if I do A10, it gives you number 4. So you see, you use 2-dimensional arrays. The 2 indexes basically give you the location of the button. That's exactly how you're going to control the how you're going to actually control the buttons right there. So and by having multiple wires, and then you have, say, 1 wire for each column or each row, and then you can control each button individually. So we don't need to worry about the lower level programming of the keypad. We're going to use a library that already does that low level programming for you. So what you need to do is essentially just connect all these leads. I think they are the female kind, and just connect them to your breadboard. And let's take a quick look at the breadboard connection. So, so this one right here is a bunch of wires over there. So what I connect to are the kind of with the GPIO pins towards the end of the extension board, kind of just for convenience, nothing else. You can use whatever pins you want. And you connect those, and there are 8 of them. Now you can press these buttons, and then you can recognize the letters. So let's look at a little program right now. The program I'm going to show you is what we're going to do is, well, actually, we're going to use a third-party library. And then we're going to actually have the keys to do something. We're going to control a couple of different keys. And so in reality, you can program each key to do whatever you want to do. And if you so inclined, you can even say, I want to do something when there's 2 keys pressed, a combo key. So I guess for our purposes, and we're not going to need to get into that, we'll just say, well, now you have a keypad. You have 16 keys in there. So you can, program the 16 keys to do something different for each one of those keys if you want. So this gives you enough input devices for your projects, if you will. You can, these have a specific, particular labels on them, like the numbers and whatever. You don't necessarily have to say, well, that is the number I'm going to use for whatever you're trying to do. You can say this number controls something, whatever you want to define this to be. So it's gives you multiple purpose. The library you want to install is this Adafruit circuit Python matrix keyword. So this is the library, and you install it with the Python pip install, just like how you install any other libraries, because this is not installed on the Pi by default. So you install this first. And we're going to also import a bunch of different libraries that actually are part of this package. And we're also going to continue to use GPIO 0 because we actually want to use this keypad to actually control our LED as well. So a couple of things you want to define. So there's a matrix keypad class, which takes the pins for rows and columns, and also the key labels, for what those keys are. So what we pass in is that the column. So actually back to the this little diagram here, this circuit diagram. And the first four, so in your case, you have actually 8 leads, right? The first four actually represent the columns, and the second four, the four leads to the right, represent the rows. And did I get the right? Actually, no, sorry, I get this wrong. Actually, the first four are the rows, the second four are the columns. So when you connect those wires, you see this, for example, this yellow wire, it's connected to pin number 5, I believe. This is GPIO pin. Hold on, it's the number 5. Let me take a quick look. Hold on. Okay, so that's right. That's the GPIO pin number 5. And so the rows 5, 6, 13, 19, they're kind of just going in this order: 5, 6, 13, 19. And then we're also going to start with 1, 2, 3, 4. And the fifth is 26. And then we'll go to the columns. Basically, the way I wire them up is in this particular order. You can use whatever pin numbers you want. And so you can, connect to like how I did it. So if you take a look at mine, back to the physical circuit here, as you see, I have 5 wires on the left and 3 wires on the right, and it's all towards the end of the GPIO pins. Okay, and just how I preferred. I just, you can do the same thing as I did, or you can do something different. That's up to you. So for if you want to replicate my program, then you just connect the same way, or you change the pin numbers. Okay. Okay, so back to this. So here, once we get those pins specified, and by the way, see this format here, we're actually essentially just using a list comprehension here. This is a little different from GPIO 0. So it's a different library, the Adafruit library. So this is kind of how you use it this way. We essentially just use this list comprehension to create a bunch of objects that's the input to this matrix keypad class initializer or the constructor. So you need this digital in-out objects with the pin passed in, the pin number in this format with the board library has these properties defined. And the reason this is done this way is actually defined to be agnostic of the different boards. Well, it supports various different kinds of microcontrollers, including Raspberry Pi. And so anyway, that's why it looks a little not necessarily not as intuitive as GPIO 0, I would say, but this is the way it's done here. I hope you can easily get it. These are the numbers that actually still represent the GPIO numbering system. And we also need to specify the key names. Those are the names that actually represent on the on the keypad. So essentially the first row, second row, third row, and the fourth row. Okay. And then you pass those in, you create this keypad object. And then we're also going to create the LED object because I want to actually have the key do something that is visible. So we're going to control the LED as our previous button example did. And we're going to define a handlers dictionary. So this is where you can create your own handlers, say for a particular key, 1, 2, A. I just did 3 here as an example. You can define the behavior or what as a function to do for any number of keys that you need to do. Okay. And then here I'll say, well, if you press number 1, I'll turn on the LED. If you press number 2, I'll turn off the LED. And if you press the letter A, and we're going to actually blink the LED for 2 times, and it will turn on for 1 second, turn off for 1 second. So you still remember this one, right? The LED blinking. And by the way, here, you cannot just, okay, suppose if I remove this, this is not right because the handler needs to be a function that you can call. It's a callable. So this is not a callable. This will execute a function call and then return a none. There's no return here, right? So this is not valid. Instead, I turn this into a lambda, which is a callable, like a anonymous function, okay? So just, be mindful of that little difference here. The only useful thing with this keypad object is to get the pressed keys. They will read what keys have been pressed on. And so you get this keys. Now, if you press 1 key, it will give you 1 key in a list. If you have 2 keys pressed or 3, whatever, at the same time, and they will be put into that list as well. So you've actually pressed any keys, and then we're going to get the corresponding handler if there is one, right? So the key is 0. So actually in this case, let's say we only will care about a single key press situation. If you press the 2 keys, and then we're still going to get just the first key, okay? And then we're going to get the handler from this dictionary here that we define. So this is the behavior, the particular handler for that key, which may or may not exist. We only define the handlers for 1, 2, and A, right? Okay, so if it actually has a handler, and we're going to invoke it like this, okay? We're going to call that as a function. And so this is how you can call that handler, okay? And then I want to give a little gap here before we read the next set of keys. So it just makes this key pressing a little more stable here. And then we're going to keep waiting for input. So we'll keep waiting for input on the keypad, and it will do something depending on the keys that you press. Okay. And the keys, if you're curious what keys are pressed on and whether it's captured this accurately, you can print this out by using the print statement if you want. So actually, let's actually do the printing first to see what keys were pressed. Okay, let's actually do this one first before we actually do the handler, which is a little more interesting, okay? All right, so so I modified this. I'm gonna run this program, okay? And now I'm going to go ahead and press the keys. And actually, so I'm going to show you this output here. You still look at this screen. If you want to, you can look at the little image on the top right corner about. I'm going to go ahead and press some buttons over there. Okay, just kind of see the output. All right. Okay, so you see a bunch of key presses, right? So, these labels that we provided, basically that will be shown as whatever was pressed. Okay. And so that's really, okay, this is not very interesting if you only can just print out what key you pressed. And oh, by the way, let me show you a combo key pressing, which is not very stable. It depends on how you press it. So let's see if I can get this going, just in case that you might want to try that out. All right, see that? I pressed the 1 and 2 together, okay? And so that's that. Okay, now I'm gonna just, execute the handler to control the LED instead. And for your program, probably you want to do something more interesting, some action to take when you press the keypad. The whole point is we're going to use this keypad to control something, make something happen. So we're going to run this again. And then this time, actually, I'm going to just switch to the physical circuit. And so you can look at this thing and look at the LED running. So, okay, so here, I'm going to try, 1, 2, 3, and A. And then we know we have handlers for 1, 2, and A, right? 3 will do nothing. If I press other keys, then nothing, there's no handler, nothing will be done. Yeah, I press 1, 2, 3, and remember 1, turn on the LED, 2, turn off the LED. A is to blink the LED twice, right? Okay, let's see if that happens. The LED is on, and let's turn this off. All right, that's off. And let's press 3, see what happens. Okay, nothing happened. Okay, let's do the blinking with A. All right, so that blinked. Okay, you can do the same thing again and again. So shows you a simple example how you can use keypad to do whatever you want, actually. Okay, so that's all I wanted to show you about the keypad.